Hello, welcome to our last video of the week, and today we're going to talk about adding and subtracting polynomials. One of the things that I need you to know is that this is one of the Common Core standards that you have to make sure that you understand and can apply for us to meet our main state standards. So please make sure you take good notes, pay attention, and write down any questions that you might have so that we can address it in class tomorrow. Here we go. So the first definitions that we're going to see is what is a polynomial. And a polynomial is defined to be the sum of monomial terms. And one of the things that I really don't like sometimes about definitions is that when they go to define something, they use an unfamiliar word sometimes embedded inside of it. So then you have to go and say, well, what is a monomial term? We know specifically that sum means the result of addition, and we can add or subtract positive and negative numbers. But what is that monomial term? And what I'd like to draw your attention to is down here, there are three types of polynomials that have special names. And the first of which is a monomial. And a monomial is defined to be a single term. And what that means is when you look at that single term, that it can have just one letter, x, which is considered a monomial. It can be a constant value of a 5, but it also could have a mixture of each, and those two that are joined together through multiplication. This is considered for us a monomial or a single term. Two pieces that are joined together through multiplication. And with that multiplication, it means that that 5 is attached to the x and has to always stay with it. It means ultimately that I have 5 x's that I'm seeing. Now more of our special names, or another one, is our binomial. And when we look at a binomial for us means that we have two terms, two different things that we can't combine together. Now lots of times in your Algebra 1 experience you saw binomials as x plus 2. And it for sure could be y minus 3 or whatever it may be. But there are two different terms that we can't do anything with unless, like yesterday's lesson, you know what x or what y is. And in this case, we don't. So the two terms are separated by one sign, one plus or minus sign in between. They are not joined together through multiplication like the monomial terms. And that's really the telltale difference between a monomial and a binomial, that you're going to see one plus or minus sign. The next special name and the last is a trinomial. So if you think of a tricycle, tricycles have 3 wheels, so our trinomials have 3 terms. 3 distinct terms that you cannot combine together. Now what I want you to notice, and we're going to talk about this more, is that there is an x here and there's an x here. But what you really want to hold on to is that they have different powers, which means they are not similar, and therefore they can't be combined together. So a trinomial is going to be separated by 2 signs. And that's what's going to join or make them as 3 distinct terms that you can't pull together. The remaining parts of our definitions are the degree of the polynomial. And what I need you to know about the degree of the polynomial is that you have to have one variable letter only to be able to determine what the degree of the polynomial is. The degree of the polynomial is defined to be, if we have one variable only, the largest exponent that you see. So if we go back to the trinomial type problem, x squared minus 3x plus 4, we have only one type of variable base that we're seeing, but the largest exponent that we have is a 2, so the degree of this polynomial for this example is a 2. And ultimately what that's going to connect with later on is specifically it's going to tell us how many x-intercepts our image would have if I was to ask you to graph that. So kind of tuck that piece of information in behind it, and it will come back before too much longer. Want to remind you for our set of directions tonight, you're going to be in the set of directions to simplify. And simplify means do as much as you can. And you want to just hold on to that as we look at our examples. Now the next things that I'm going to give you are going to guide us through our steps. This really should go in the step part of your template if you're using that. And it really focuses on how do I know what I can combine together and what I can't. Notice again, combining similar terms means in order for me to simplify, I have to say what is the same and what is not. So there's two things that make something similar. They have to have the same base like we mentioned with our trinomial. So that's the first thing that you need to consider. What has exactly the same base, and those are your bottom letters. And then the next thing is that they have to have the same exponent or power. And what happens is when you then go to combine those similar terms, once you check and say, all right, this has the same x and they both have the same x to the second, then the action that you take is to add or subtract the coefficients only. And I want to remind you that the word coefficient is the number that's attached to the variable in front of it, joined through multiplication. So when we had that monomial term of 3x or whatever it may have been, the 3 is our coefficient. And that's what we're going to add or subtract, the action that we're going to take. But first we have to determine what is similar. Now as we go through these examples, I need you to still hold on to the fact that we have to follow order of operations. So if you see a parenthesis, what we're looking for inside is what's similar or not. If you don't have anything similar, look for the power. If there's no power, which there won't be tonight, outside of the parentheses, you look in front and you say, okay, is there anything there that's going to change what's inside? So those are the three things that we're going to follow today. Let's look at our first example for our end of our part 1. All right, in this example, you'll notice that we have two parentheses. So again, following order of operations, I'm going to look inside and say I have a 3a squared and I have a negative 5a. Though they share the same bases, the powers are different. So that means I cannot combine them together. So then I look outside and say, well, is there an outside power? And there's not. Then I look directly in front and say, is there something inside that's going to change what's inside? And there's not. So what I'm going to do here is I'm going to drop my parentheses, keeping everything exactly the same. And now I start to assess the second parenthesis in the same way. Now you'll notice here that this one doesn't have a coefficient shown, an actual number shown. And so hopefully you remember that that's a hidden number 1, and I'll actually add those in for any times I have a variable base but there is no number shown. But again, we also have an a squared and an a with different powers, so I can't combine them. No outside power. And in front there's a plus. And a plus says let's keep everything in the same with the parenthesis that follows. So I'm ultimately going to drop those parentheses as well. And I'm going to show it as a negative 1a squared and a positive 2a and a positive 1. So at this point in time, we're now down to addition or subtraction. We've taken care of our check of what we can combine together and what we can't. And we've looked in front to see if there's something multiplied, which we would use distribution to do so. Now that we're down to addition or subtraction, it's combined similar terms. So the first term that I see is a 3a squared. And what I'm looking for here is where else do we have any other a squared terms? So if you scan your polynomial, you'll notice that I have a negative 1a squared. And again, you're going to remember that the sign of a term is in front of it. So if I have 3a squareds and I take 1a squared away, I have 2a squareds left over. Notice that I did not change the power at this point. I kept it as a power of 2 because I haven't changed how many a's I have. I just have changed the coefficient in front. I've added or subtracted the coefficient. So then I'm going to move on to my next term, which is a negative 5a. And I scan my polynomial for other a's, and lo and behold, I have 2 a's. So as I add or subtract the coefficients, negative 5 plus 2 gives me a negative 3 of the a terms. And again, notice I didn't change my powers at all. And the last step, constant with constant, 2 plus 1, for 3 for our final answer. You can't go any further because these bases have different powers, so you are done at this point in time. The last example that I want to show in part 1 is a subtract sign, just so that you can see what happens, and then we'll build off from that. Same thing that we did before. Notice we have an x squared and we have an x, and I'm going to add that coefficient of a 1. Different powers, so we can't combine them together. No outside power, nothing in front to change it. I'm going to drop the parentheses and rewrite. At this point, I'm going to look at my second parenthesis. Base of an x squared and an x, but with no power, which ultimately means 1. Can't combine because they're different terms. No power outside, but then I have this subtract sign. And this subtract sign says for us that I need to take the opposite sign and I need to distribute that opposite sign to every single term that's inside of that parenthesis. The key thing is to write what you say. So the opposite sign of a positive 2x squared is a negative 2x squared. Notice that's what I write. The opposite sign of a positive 3x is a negative 3x. Notice that's what I write, and I'm dropping my parentheses as I do this. The opposite sign of a negative 2 is a positive 2. So each time you're doing this, whatever you say that you're getting for a result is what you're writing. And you're dropping the parentheses as you distribute. And really hold on to that part. So I have now, as we combine similar terms, we're down to addition or subtraction. I have 6x squareds. I scan along. Remember that the sign of a term is in front of it. 6x squareds, take away 2x squareds, leaves me with 4x squareds. The next term, my x. I have a negative 1x and I have a negative 3x. My signs are the same, so I add the numbers and keep the sign, but don't change the x. And then that positive 2, because there's no other constant, just comes down to join our answer, and we're done. So this concludes our part 1. Please follow for examples 3 through 7 in part 2.